now we're getting into one of my 2 sessions that we're going to do these 2 days. And in this next session, now we're going to get into what is very often now referred to as physical AI. We're going to talk about mobility, autonomy, and I want to be very clear at the very beginning of my presentation about the very specific argument that I want to make in this session. And basically the argument is that we are currently living at an extraordinary turning point in the way that we are developing a very particular kind of AI, and it's an AI that is increasingly referred to as physical AI. This is what NVIDIA has been referring to this, so you might hear this term more and more. Now, the reason physical AI matters, so what is physical AI? Physical AI matters because this is the kind of AI that is increasingly powering our physical systems, and in particular, our robotic systems. Now, if you have been online anytime over the last few months to in the last maybe up to a year, you may have come across any one of these viral videos. And what we should take away from a video like this is that the capacity, the capabilities of these robotic systems are developing at an extraordinary pace today. Something new has happened only very recently. And so in this session, what I want to do is I want to explore why this is happening now. Like, what is unique in the last 6 months to a year? What are the technologies that are driving this shift that I'm describing? And then I think what I imagine most of us in this room care about is, okay, so what does this mean for some of the industries that we care about? How does this impact my job? How does this impact the companies we work at? Okay, now before I get into it, I want to kind of refer back to something I said this morning about how it can be very challenging to talk about new technologies. And part of the reason for that is very often our minds come with these very strong associations. And we're going to talk a lot about robots in this session. Now, the term robot brings to mind a certain connotation that has been shaped by decades of pop culture, right? We're used to systems like Rosie the Robot from the Jetsons, or C-3PO from Star Wars. What I really encourage us to do is to actually expand our understanding of what a robot means, what that term is actually referring to, because essentially what we're talking about are computers that move. Any computer where there's movement involved is essentially now we could think of, okay, that's a robot. And when we think of it in this way, if we think about movement, then we start to understand the number of industries where this is going to have an impact, right? So we're talking about farmerless tractors. We're going to talk flying cars, flying taxis are coming online, driverless cars, of course. We're going to have robots in our homes, cleaning our robots cleaning our living rooms. We'll talk a little bit about drones. We'll build on some of what David talked about with drone delivery, for example. And Amazon, just in the last few years, have deployed for the first time these fully autonomous robotic systems in a warehouse environment. Now, just to take this one step further, the other aspect that's really important here is this concept of autonomy, right? Because ultimately what we care about is not just computers that move, but being able to move entirely on their own, so autonomous movement. And this is somewhat of a famous quote from Jensen Huang, the CEO of NVIDIA, says, in the future, anything that moves will be autonomous. Now, at the very beginning of my presentation, I mentioned that we are currently living in this really big turning point in the way that we're building these kinds of AI systems. But I want to be very specific about what I'm actually referring to. I'll read what this headline says in a moment, so you don't need to read it. I'll explain it in a moment. Before I do that, just to understand how we actually build robots and get robots to do the jobs in the world that we care about, if you're a robotics developer, what you do is you take a job, you break that job into these discrete tasks, and then typically you have to write the code to get the robot to do that specific task. That's how we've essentially built robotic systems for most of its history. What this headline is pointing at, it's a revolution in how robots learn. It says, a future generation of robots will not be programmed to complete specific tasks, so essentially the process I just described. Instead, they will use AI to teach themselves. Now, one thing to point out about this headline, this is from less than a year ago. This is November of last year. What I'm going to talk about in this presentation is very new. It has only been the case in the last 18 to 24 months, where this is sort of how we build physical AI. In fact, if you were to go back to 2022, that's not that long ago, it was very unusual to be using AI in the way that we use it today for programming and building robotic systems, right? So here's a way to understand it very clearly, very visually. So this was a paper that NVIDIA published at the end of 2023, 2023, where basically they had programmed this robotic hand to complete these complex motor skills. It's very challenging to get a robot to do this. Now, what was really interesting about this paper, for the first time, no human programmer wrote the code that powers this robotic hand. Essentially what they did is they turned to a large language model. In this case, they used OpenAI, so they had GPT-4 essentially write the code. That code would then power these simulated hands that basically learn how to do their job in what is essentially a video game. We're going to talk a lot about simulation in this presentation. The simulation then gives feedback for how to improve the code, and then that code gets sent back to GPT-4, which writes the code. So you can see this self-amplifying system. Now, there's one ingredient that's very important in this whole process that has really unlocked this whole world of robotics that we're talking about, which is the implications and the role of simulation in particular, right? Because we have all of these examples over many years of all of these robots doing impressive things, achieving these complex tasks. What doesn't really get talked about very often or enough is the role that simulation and essentially, again, what are like video games are used to train and design these robotic systems. And the reason ultimately why we care, why this matters, is because now we're starting for the first time to see systems like this, right? This is the Atlas robot from Boston Dynamics.